Hey there, Math 8. Welcome back. We got like 5 classes left until winter break. So you're doing a great job. Hang in there. We can get through this. 5 more, about 4 more assignments maybe, and you will get a well-deserved break for a few weeks. And then we get to move into the new building, hopefully. So we're going to start today doing the second section of Chapter 11. We are going to learn about a bunch of special angle pairs. Really, I'm just going to give you several definitions, and then I'm going to go over several examples, and you'll be ready to go. So let's get started. All right. There we go. Maybe. Wait for it. I think that's good, probably. All right, so hopefully you have printed out or you have received the guided notes. I think it'll be much easier if you have done that for this section for sure. And let me get started. So you can see here, I want to make it a little bit bigger. There we go. You can see here that our objective is to identify special pairs of angles, and just as important, how their measurements are related to each other. And if you do this, then you can use these to find missing angle measures, which is really our goal. So let me go over a bunch of these, or several, like 4 or 5 of these special types of angles, and we'll be ready to do some examples. So first up, we have this thing called complementary angles. That is any 2 angles whose measures add up to 90 degrees are called complementary angles. And I'm going to make a couple diagrams over here. In diagram 1, so diagram 1 is going to look like this. And what I have here is a right angle. I'm going to put point A at the top, and point B is going to be my vertex. I'm going to call this point D. And so that angle is a right angle, which means it's 90 degrees. And if I take that angle and I split it into 2 angles, I'll put a C out here. Now I have 2 angles that together they add up to 90 degrees. So angle ABC, of course, angle ABC is this top angle, and angle CBD, that is this bottom angle. Together, those add up to 90 degrees, so they are called complementary angles. Or sometimes people say they are complements of each other. And then, the 2 angles don't have to be connected, though. I could just have an angle over here that is like 60 degrees, and I think I'm calling that angle P, just calling it by its vertex. And then I could have another angle down here that is 30 degrees, and I'll call that angle N. And angle P and angle N are also complementary. They are just 2 random angles that happen to add up to 90 degrees. That's what makes them complementary. They add up to 90 degrees. All right. Next up, we go to supplementary angles. Supplementary angles are very similar to complementary, except now they are any 2 angles that add up to 180 degrees. So we can do this one a little bit quicker. It's pretty much the same, except this first thing here. I have a line here, and I'm going to put a little point on that line and call it point B. Now, we know that a right angle is 90 degrees. Do you guys know what that is called? That is actually called a straight angle. And a straight angle is, or a line, is 180 degrees. So if I take that, and then maybe I'll put a little A over here, and a little D over here, and I'll draw a line up here and split it into 2 angles. And now I have two angles that together they make the straight angle, which was 180. So angle ABC, which is this angle, and angle CBD, which is on the other side, added together, they make that straight angle, which is 180 degrees, so they are called supplementary angles. And just like up in the first example, I could just have two random angles, like I could have this angle P that is 100 degrees, and I could have this angle N that is 80 degrees, and angle P and angle N would also be supplementary angles because they add up to 180 degrees. All right, we're moving. 3 more to go. So now I've got this thing called adjacent angles. Adjacent angles are two angles that have the same vertex. Okay, so they have to have the same vertex, and they have to share a common side. So let me draw a diagram here. And I'll draw the diagram I typically draw. We'll call that A, that B. This time I'm calling this one C. And I'm going to draw this line down the middle and call it D. All right, so first, there are two angles here that have the same vertex. And that is, they both have vertex B. All right, the vertex for both of them is point B. They also share a common side. This line down the middle is shared by both angles. The common side is BD, right? So they fit the description. They share a common side, and they have the same vertex. And you know, there's one thing I did not include there, and that is they cannot overlap each other. And these do not, right? They split at this side right down the middle. So what we would say here is that angle ABD, that's this angle, and angle DBC, that's this angle, are adjacent. All right? They share a common side, and they have the same vertex. All right, that brings us to a big one here. This is an important one that people often mess up, or they don't see it very well in a diagram. It is called a linear pair. Look what's in the word linear. The word line is right there in the word linear. A linear pair are two angles that are adjacent angles. Okay, so that means they share a common side, just like we did up here. Their other sides, I said that's the outsides, right? So that'd be like this line BC and BA, the outside, not the side they share, but the outside of each angle, form a straight line. So that might look like this. I'm just going to name this angle 1 and angle 2. That makes it easy. Notice they share a common side, right? They are adjacent angles. That means they share a common side. That's the line down the middle. And the other sides form a straight line, right? If I made this side blue, and I made this side orange, these are the two sides that make actually a straight line. When you take a straight line and you split it into two angles, that is called a linear pair. And as we learned before, these two angles are always supplementary because together they form a straight line. So these two angles always add up to 180. We'd say angle 1 and angle 2 are a linear pair. But the most important thing is, can you recognize a linear pair? Because they make a straight line on the outside, and they add up to 180. All right, I've got one more for you. It's on the back. And this is vertical angles. All right, vertical angles are when two lines cross. All right, so that's like two lines cross. I'm saying like they make an X. The angles that are opposite each other are called vertical angles. So I'm just going to draw over here two lines that cross each other. That'll do. And I'm going to number the four angles. 1, 2, 3. Right? I've made four angles by these two lines crossing. Well, the angles that are opposite each other are called vertical angles. And vertical angles are always have equal measures. So which ones are the vertical angles? Angle 1 and angle 3 are vertical angles because they are opposite each other. And angle 2 and angle 4 are a pair of vertical angles. That means that the measure of angle 1 equals the measure of angle 3. And I want to point out that this little m in front of the angle symbol means the word measure. The measure of angle 1 equals the measure of angle 3, and also the measure of angle 2 would equal the measure of angle 4. Vertical angles always equal. All right, so you now know all the relationships you need to know to do these examples. Let's try to whip through the examples. These are all very similar examples. I can't tell you. They're very similar examples to the ones you're going to see on Delta Math. All right, so work through them. You'll have no trouble on Delta Math, I think. All right, example 1 tells me that angle A and angle B are vertical angles. Well, I just learned that vertical angles are equal to each other. So if the measure of angle A equals this, and the measure of angle B equals this, then that must mean that 2x minus 4 equals x plus 1. And I have an equation to solve. And I don't really, well, I'll solve it. So I would subtract x from both sides, giving me x minus 4 equals 1. I would add 4 to both sides and get x equals 5. So I have found the answer. They asked me to find the value of x, and I found out that x equals 5. The important thing was that I knew the vertical angles were equal, so I made these two amounts equal to each other. Example 2. Angle A and angle B are supplementary angles. Well, I just learned that supplementary angles add up to 180. So that means if angle A equals this, and angle B equals this, then I must be able to add those together, 5x plus 25 plus, so I'm taking angle A, and I'm adding angle B, and when I add those together, I must get 180. And I have another equation to solve. I'd add my x terms together and get 8x. I'd add my two numbers together, 25 and 19 is 44. Adds up to 180. I'm not going to spend a ton of time on this because I know you know how to solve equations. I'd subtract 44 from both sides and get 136. I would divide by 8 and get x equals 17. But make note, that is not the answer, because they asked me to find the measure of angle B. So I found out what x is, but now I'm going to take x and I'm going to stick it in to the measure of angle B and find out that the measure of angle B equals 3 times x, so 3 times 17 plus 19. Well, that would be 51 plus 19, or 70. The measure of angle B is 70. All right, we're going to get a little harder, I think, now. The measure, let's see, example 3 says that the measure of angle AED, so where's A? A is right here, E is right here. So AED would be this angle. And they told me that that angle is 85. They want me to find the measure of angle AEI. So A, E, oh, I's down here, I. So that's this angle. And what you should recognize here is, so let's call that angle just X. I need to find what X is. And what you should recognize is that together, these two angles make a straight line. The 85 and the X, together the outside of the orange angle and the outside of the blue angle make a straight line. I'll make that straight line pink. These are what is known as a linear pair. When the outside of the angle makes a line, known as a linear pair. And a linear pair, we learned on the front, adds up to 180. So X plus 85 makes 180, therefore X is 95. And that means the measure of angle AEI, which I called X, is 95. We go to example 4. All right, this is a little known thing, but look, there are 3 angles here. Let me put them in different colors. We have angle A in blue. Ooh, look, I have this little box here, which means this is a 90-degree angle. We'll just put that one in red, 90 degrees. And then last, I have this little 20-degree angle, which is orange. Now, this is not a linear pair. However, it's the same concept. Look where the blue angle, the outside of the blue angle and the outside of the orange angle together make a straight line, which means that all 3 of these angles together make a straight line, so all 3 of them add up to 180. Or A plus 90 plus 20, the 3 angles add up to 180. Now, I know you can solve that, so we'll just give to you A equals 70. But the hard part is, do you see that those 3 angles add up to 180 because they make a straight line? They're like a linear pair. Maybe they're called a linear trio. All right, how about example 5? We're almost done, guys. Example 5 has a bunch of vertical angles. You know, I think the first angle we should look at here is angle D. I want you to highlight I want to highlight these 2 lines. So those 2 lines are lines that cross. And over here, I have a 30-degree angle, which means over here, those are opposite angles made by 2 lines that cross. This is what you have to be able to recognize. Therefore, they are vertical angles. And so D must equal 30. Because they are vertical angles. And I think I can do the same thing with these 2 lines. The lines that make this 117. So this line and this line, the 2 orange lines. The 2 orange lines make an angle here that's 117, and they make an angle here called angle E. So E must equal 117 because they are vertical angles. All right, this last one's going to be hard because I've messed up the drawing so much doing it in pen. But the angle we have left is F. And so here's what I'd like to show you about F. So look at this straight line. Let's see, what line do we want to do? How about, let's look at this straight line right here that I'm coloring in purple. All right, this straight line is made by 3 angles. It's got an angle here that's 30. It's got an angle here that's 117. And then it's got an angle here that's F, and I'm back on the line. Those 3 angles, just like the 3 angles up here in this example, the 3 angles together form the straight line on the outside. So together, they must add up to 180. So that means that 30 plus 117 plus F adds up to 180, and I can figure out F, right? I could add those together, subtract from 180, and if I did that, I think I would get 33. All right, 2 more examples and we're done. 6. All right, so the first thing I see in 6, is this. Look, if this is a right angle here, that means it must be a right angle over here also, because together those 2 right angles make a straight line, 180 degrees. And if this is a right angle over here, it is made by the 64 and the x. Together they make 90 degrees. They're complementary to each other. So x plus 64 equals 90, and if I subtract 64, I get 26. This is 26. Now, the next thing I'd like to point out is this angle over here that's not marked. I need to know this angle that's not marked. I'm going to call it angle 1. And I can get angle 1 because look at these 2 lines, you guys. This is the thing you got to see. These 2 lines make an X, where the 26 and the 1 are opposite each other. These are vertical angles. Therefore, if this side is 26, then this side is also 26. And why is that important to me? Because right here, this box is a 90-degree angle. And angle Y is made up, this arc for angle Y is made up of the 90 and the 26 together. The Y is equal to the 90 plus the 26. So it's 116. All right, last one. Woohoo! All right, in this one, again, it looks like I have a little box here, which means that this angle and this angle together make a 90-degree angle due to that little box right there. So that means that x plus 26 equal 90. They are complementary. And if I subtract 26 from 90, I get 64. The x is 64. And now I can get the y, because right here there's a 90-degree angle, and here I've got lines crossing. That means that this side, I've messed this up, this side would also, these are vertical angles, this side would also have to be a 90-degree angle. And the 64 and the y together add up to this 90-degree angle. 64 plus y must make 90. So if I subtract 64, it must be 26. All right, I know that was a long one. I thought the examples were worth it. Those are sometimes hard to see. I will see you guys Monday. Good luck on the homework. You can do it.